Welcome back. Okay, I promised you to put some stuff together here, so let's do it. So we're going to find different examples of power series. That converge on just a given interval. Now, there is a problem that you guys have that makes it change, and you can adjust this, and that's sort of part of what I want you all to do. But we're going to do this just on a simple interval, -1 to 1. So we're going to find a power series that converges on first -1 to 1. Okay, so the power series that converges on -1 to 1 is just our geometric series. Okay, all right, if you look at 1, that's going to be, that's going to definitely diverge. And at -1, it's alternating between +1 and -1. It's still divergent. That's still considered divergent. Okay, all right, so this, our geometric series. Okay, and let's say that I gave you let's say I gave you the interval 2, 4. Let's actually no, let's go even bigger. Let's go 2, 6. Okay, well that means that this has a radius of convergence of 2, right? Because there's 4 between them. So if I wanted to find a power series that converged on 2, 6, I could do the same sort of thing. What I'm going to do now, it's going to be 1/2 x minus 3 squared. Okay, so radius of convergence should be 2, okay? 1/2 6 minus 2. And the center is 3, and that's given by actually 1/2 6. That should have been x minus 4, huh? One half of 6 plus 2. Okay. So that's how I got those numbers. But basically, it's the same sort of thing. This is, why did I put to the 2? Should be to the n. Okay. So it's basically the same sort of thing. Okay. And you could do that with any numbers. Okay. All right. Let's go with B. So B, it's asking us for power series that converges on -1 to 1, which includes the 1 on the right endpoint, but not the 1 at the left endpoint. Okay, well, we're going to use a P series here. So let P be between 0 and 1. Okay, and we're going to consider the sum, n goes from 1 to infinity, -1 to the n, x to the n to the p. Okay, this is basically like one of those first examples we did. Let's look and see what happens at 1. At 1, we're going to get an alternating p series that decreases. I mean, the terms decrease, right? So at 1, this is going to converge. At -1, you're just going to get a regular positive p series. Okay. All right. C. You're going to change it around. Well, again, almost the same thing. I'm going to have to change it around a little bit. And here we're going to consider just x to the n over n to the p. Okay. we'll get alternating at -1, okay? So that's where this will converge. That was another problem that we did, right? So we had, you could consider that something like this, okay? Yeah, the 3's in there, but basically without the 3, that's what we're doing. That other one was this one. It was a P series with the -1 to the n, okay? All right, last one that we could get. What about D? How would we get something to converge there on -1, 1? That's right, a P series again, but with different P's. Let P be bigger than 1, and now consider now if you want to be fancy and consider -1 to the n, no one's stopping you, and that'll still work, okay? But either one will do, okay? I'm a fan of being as fancy as you need to be, but no fancier, all right? Okay, that pretty much wraps up 8.5, okay? But we are going to get into 8.6 too, so I'm going to sort of blending together, but that's the next section, and it also deals with power series. I'm all queued up to do it right here, okay? All right, see y'all in the next set of videos.